Hi. So this video is devoted to the goodness of fit in terms of variables and the entire model design. And as I told you before, it's all based on the value of residuals. So first of all, we deal with standard errors. And standard error stands for the measure of reliability of estimators. In our case, beta 0 or beta 1. If you want to put this in the informal way, it describes how well changes in the independent variable can explain changes in the dependent variable. So the smaller the value of standard error, the higher is the degree of precision. And this is how it's calculated. So first of all, you take the sum of all the squared residuals, divide by n minus 2, where n stands for the number of observations, take the square root, and it will be equal to the value of standard error. So it's directly related to the value of residuals. In output of the regression model, you always have standard error in the second column. So this is the value of coefficient, and this is the value of the standard error. So please keep in mind that it's always positive because you take residuals to the power of 2 and then you take the square root. So it's not possible to have a negative standard error. So this is when it comes to the variables. As for today, we will also discuss how to determine whether the variable is statistically significant or not based on standard errors, because t-ratio and p-value are computed based on the standard error. When it comes to the goodness of fit of the entire model, we use a bit different statistics. So take a look at this graph first. So this stands for the average value of independent variable for the entire sample. So if you take all the countries for all the periods and calculate the mean value of, let's say, Gini coefficient, this is what you have. Naturally, it does not depend on the value of independent variable. So this is our regression line. This is predicted value of y, and this is empirical value of y. So this distance stands for the difference between empirical value of y and average value of y calculated for the entire sample. This is the distance between average value and predicted value. So very informally, you can take it as the proportion of variation in the dependent variable, which is actually explained by the model. And this is the distance between predicted value and empirical value. So this is the proportion of variation which is not explained by the model. And together, they constitute total variation, total distance between average value of y and empirical value of y. So you calculate TSS as the square of this distance. Again, we take square because we are not really interested in magnitude. This distance can be positive, this distance can be negative, and it makes no difference for us. And RSS is calculated as the square distance between empirical value of y and predicted value of y, depending on the value of x, of course. So you calculate R-squared statistics as the difference between 1 and the ratio of RSS to TSS. Again, very informally, R-squared describes the proportion of variation in dependent variable, in our case in y, which is actually explained by the model. always when you do econometric regression, regardless of the type of software you use, you will always have information about the value of R squared in the output. So our model explains approximately 21% of variation in dependent variable. It's hard to say whether it's a high value or a low value, because students frequently ask this question, like, I got R squared equal to 0.5, is my model good enough? Of course, the higher the value of R squared, the better, but you should also take into account the nature of data and the type of model you estimate. So usually for macroeconomic models, it's relatively high. For high frequency data, like for instance in financial modeling, it's relatively low. So it's definitely hard to say. What you can say, however, is whether this proportion is statistically significant or it's not statistically significant. And in order to figure this out, we will have to discuss the notion of statistical significance first. So we will get back to this issue. As for this topic, that was it, and thank you for your attention.